All right, everybody, in this problem, we are going to be looking at sewer flows, and we're going to look at calculating and quantifying how much water is actually flowing down our sewer system, and we want to report that information in terms of MGD, or million gallons per day. So in this example here, we've got two different manholes, right? Manhole A and manhole B, right? Remember that wastewater is traveling, in this direction in this example, from one manhole over to the next manhole. And so what we do oftentimes in wastewater, we want to be able to quantify how much water is flowing. So one of the things we need to do is we need to look back at our formula of Q equaling A times V, or area times velocity. And so what we'll often do in wastewater is we will add some dye here into manhole A, and then we will start a timer. And then we will measure how long it takes before we can then start to see that dye in manhole B. And so what do we need to know? We need to know both the time component of how long that water took to travel from A to B. We also need to know the distance, right? The length from manhole A to B. So in this example, we'll say that the manholes are 250 feet apart. We started our timer, we dropped dye, we waited till that manhole B. Our person we're working with, our coworker's like, okay, stop. We look and we see a time of, let's just say, 93 seconds. Okay, so from there, we can figure out our velocity, right? So our velocity is going to be equal to our distance over time. So in this case, what do we've got? We've got our distance of 250 feet. We've got our time of 93 seconds. If we had time in 1 minute and 33 seconds, you want to make sure you convert it all over into seconds. Because what do we want to end up ultimately here? We want to end up with feet per second, right? Like we do in all of our velocity or our flow calculations. So in this example right here, we pull out our handy dandy calculator. I do 250 divided by 93, and I get to a speed or a velocity of the water traveling at, we'll call it 2.69, and those units are feet per second. Right? So that becomes our velocity right here, 2.69 feet per second. So what do I need? I need my area. In this example, we're going to be given a cross-sectional area that looks like this. This is the area of our manhole we're measuring. We know the width of this channel. We measured it to be 10 inches. We also measured a depth of this water. In this example, we'll say to be 4 inches. So based on the profile of water running through our system, we can calculate the area and plug that in order to calculate flow. So in this example here, I've got 4 inches times 10 inches. That's going to give me 40 inches squared. Now, velocity is in feet per second, so I want to multiply the area by square feet, not square inches. If you multiply by square inches, you're going to get some really wonky number. So now I take this 40 inches squared. I'm going to divide that by 144 because there's 144 square inches per square foot. Again, pull out my handy dandy calculator wherever I left it. 40 divided by 144, and that's going to give me 0.277, so we'll just say 0.28, and that's going to be square feet. Remember that the more digits you leave in your calculator, the more accurate your answer is going to be, right? I recommend leaving it all in your calculator and just running one number after another, and then round at the end. I, of course, writing on the board and rounding somewhere. So just keep in mind your final answer is going to vary slightly depending on where you decide to round. The more numbers you keep in your kind of initial calculations, the more accurate your final answer is going to be. So we've got our area now, 0.278. That's what I'm going to plug in here, 0.278 square feet. If we look at our units now, we're going to have square feet times feet per second. That's going to get us 2 cubic feet per second. All right, so what is 0.278 times 2.69? we get to 0.7, we'll just call it 0.75 up here, cubic feet per second. So there's our flow rate. Right? We're able to quantify it, but now what we need to do is we need to report it in terms of MGD, right? Million gallons per day. So what do I need to do? I need to convert. So in order to get rid of cubic feet, I'm going to rewrite this so it's a little bit clearer where seconds are, right? Seconds are on the bottom here. In order to get rid of cubic feet in my conversion factor, cubic feet going to go up top or down below? It's going to go down below, right, on the opposite side. I'm bringing in gallons. Remember that there are 7.48 gallons for every 1 cubic foot. I'm still writing lefty here, so if my writing's a little sloppy, you need clarification, let me know. I'm then going to, so I've now taken care of cubic feet. I need to take care of seconds. Right now I've got gallons. I don't want gallon per minute. I want really gallon per day. And then from there, million gallon per day. So what am I going to do here? I am going to go from, let's just say I look at the conversion sheet. I remember, okay, there's 1,440 minutes in a day. I know there's 60 seconds in a minute. I did this oppositely, but seconds is going to cancel out here. Minutes is canceling out here. So what are we left with across the top? I've got gallons, and that's it. What am I left with across the bottom? I've got days, and that's it. So I'm left with gallons per day. So now I take this calculation here, my 0.75. In my calculator, I've got 0.74782, however you want to do it. I'm going to multiply by the 7.48. I'm going to multiply by the 60. I'm going to multiply by the 1440. And that gets me to 483295.1 gallons per day. Remember to convert from gallon per day to million gallon per day. You're always just going to divide by a million. Make sure you hit those zeros correctly in your calculator. Divide it by 1 and then count out the 6 zeros. 1, 2, 3, 4, 5, 6. And you should be left with 0.48 MGD or million gallons per day.